On this 2014 to 2018 GMC Sierra 1500 with the 5.3 gas engine, P0010 points us toward the intake or single camshaft position actuator control circuit. In plain terms, the ECM may be commanding the cam actuator solenoid one way, but the circuit feedback is not matching what it expects. The truck may run normally, or it can have rough running, reduced performance, timing-related drivability complaints, or a check engine light with no obvious symptom. Broadly, think possible oil condition or oil pressure issues, wiring and connector problems, the cam actuator solenoid circuit, or a control side problem. Start with the basic system checks first, then stay with a structured diagnostic approach so you do not jump past the easy causes. Before getting into testing, understand what the ECM is watching. For P0010, the monitor runs with the camshaft position actuator solenoid valve commanded on, the ignition switch in run or crank, and ignition voltage greater than 11 V. Once those gates are met, it runs continuously. The code sets when the commanded state does not match the actual state for greater than 5 seconds. That is why this diagnosis is built around command, response, and the integrity of the control and low reference circuits. With the ignition on and the vehicle in service mode, first make sure there are no related crankshaft or camshaft position codes active. If those are present, check what they mean first, because they can affect how this test behaves. If none of those related position codes are set, check the oil side before blaming electronics. Oil level, oil condition, and oil pressure are critical to this cam actuator system. Dirty, contaminated, low oil, or low oil pressure can all affect actuator operation. Next, with the engine idling, use the scan tool to command the intake single camshaft position actuator position from 0 to 20 degrees and back to 0 degrees. Watch the control circuit low, open, and high test status. The expected status for each one is not run or OK. If one of those statuses is not in that expected state, move into circuit testing. If they are not run or OK, command the actuator again from 0 to 20 degrees and back to 0 degrees, then watch intake single camshaft position variance. During each commanded state, the variance should be less than 2 degrees. If the variance stays less than 2 degrees, keep watching that same variance while wiggling the harness and connector at the camshaft position actuator solenoid valve and at the engine control module. If the variance jumps to 2 degrees or greater while you move the wiring, repair the wiring, terminals, or connector condition that caused it. If it stays less than 2 degrees, reproduce the operating conditions for the code. You can also drive it under the captured failure conditions if those are available. Then verify whether P0010 resets. If it does not reset, the system is currently OK. If it does reset, continue into circuit testing. For circuit testing, turn the ignition and all vehicle systems off. Then disconnect the camshaft position actuator solenoid valve connector. Give the vehicle enough time to go fully to sleep. It may take up to 2 minutes before a ground or low reference continuity test is accurate. Test between low reference circuit terminal 1A and ground. You want less than 10 ohms. If it is 10 ohms or greater, disconnect the engine control module connector and test the low reference circuit end to end. From terminal 1A at the component harness to the other end at the control module harness, you want less than 2 ohms. If it is 2 ohms or greater, repair the open or high resistance in that circuit. If it is less than 2 ohms and the circuit checks are good, the supported path points to the engine control module. If the low reference to ground test was less than 10 ohms, turn the ignition on and check the control circuit with a test lamp between the control circuit terminal 2B and ground. The lamp should not turn on. If it does turn on, turn the ignition off, remove the test lamp, disconnect the engine control module, then put the vehicle back in service mode. Now test voltage from control circuit terminal 2B at the component harness to ground. The expected value is less than 1 V. If it is 1 V or greater, repair the short to voltage on the control circuit. If it is less than 1 V and the circuit checks point back to the module, the supported path is engine control module replacement. If the test lamp did not turn on during that control circuit check, turn the ignition off, remove the lamp, and connect a 3A fused jumper wire between control circuit terminal 2/B and ground. Start the engine and command the intake/single camshaft position actuator position from 0 to 20 degrees and back to 0 degrees. The scan tool should show the intake/single camshaft position actuator control circuit low test status as malfunction. That confirms the ECM can recognize the forced low condition. If the scan tool does not show the low circuit test status as malfunction, turn the ignition off, remove the jumper, and disconnect the engine control module connector. Test from control circuit terminal 2B at the component harness to ground. The expected result is infinite resistance. If it is less than infinite resistance, repair the short to ground on the control circuit. If it is infinite resistance, test the control circuit end-to-end from the component harness to the control module harness. That circuit should be less than 2 ohms. If it is 2 ohms or greater, repair the open or high resistance. If it is less than 2 ohms and the circuit checks pass, the supported path points to the engine control module. If the scan tool does show the low circuit test status as malfunction, then the control circuit response is being seen correctly. At that point, check whether the related camshaft actuator performance code is present. If it is, turn the ignition off and inspect the camshaft position actuator magnet, the camshaft position actuator solenoid valve, and the camshaft position actuator for wear or visible damage. If wear or damage is found, repair or replace as necessary. If that related performance code is not present, continue with testing the camshaft position actuator solenoid valve itself. For the static component test, keep the ignition off and disconnect the camshaft position actuator solenoid valve connector. Measure between control circuit terminal 2B and low reference terminal 1A. The expected coil resistance is 6 to 12 ohms. If it is not between 6 and 12 ohms, replace the camshaft position actuator solenoid valve. If it is within that range, test from each terminal of the component to the component housing. That should be infinite resistance. If it is less than infinite resistance, replace the camshaft position actuator solenoid valve. If it is infinite resistance, the static test is okay. For the dynamic component test, ignition off. Disconnect the camshaft position actuator solenoid valve connector, again, if needed. Connect a jumper wire between low reference terminal 1A and ground. Then momentarily connect a 7.5A fused jumper wire between control terminal 2B and B+. The solenoid valve should turn on and off as you connect and disconnect the jumper. If it does not turn on and off, replace the camshaft position actuator solenoid valve. If it does, the dynamic test is okay. After the repair is complete, verify the repair and confirm the code stays gone. Keep the verification separate from the circuit and component tests. Clear the fault, reproduce the operating conditions, and make sure P0010 does not return. The takeaway is simple. Diagnose P0010 as a command versus response circuit problem, but do not skip oil condition, oil pressure, connector movement, or the low reference and control circuit checks before condemning a component. For more diagnostic training, visit stepdiagnostics.com.